Hello everyone. So let's move to new subjects which are the sum of products and the product of sums. So before diving into them, we need to know something which is called the domain of a Boolean expression. For example, if you have this Boolean expression a complement b or a b complement c, what is the domain of that Boolean expression? So in each Boolean expression there is a set of variable. Here we've got a, b, c, and here for example we have got a, b, c, and d as well. So we've got those four variables. So the number of the variables which is inside that Boolean expression is going to be the domain. For example, the domain of this Boolean expression is going to be a, b, and c. However, for this one is going to be a, b, c, d, and e. For example, we have e here as well. So any variable that is participated in the Boolean expression is going to be one of the domains of that Boolean expression. So there are two standard forms of the Boolean expression, and they are sum of products and the product of sums. So you can easily convert any Boolean expression to one of those forms, sum of products and the product of sums. When we say sum, we refer to the or, and when we say products, we refer to the AND gates. So it's going to be much easier to implement the truth table or analyze the Boolean expressions if they are in the standard forms of sum of products and the product of sums. So let's move to the sum of product. When we say this term sum of product, that means there is a sum which sums some products together. Here we've got a and b, which is going to be a product term. Here we've got abc, which is a product term, a and b and c, and they are already together. So it's going to be sum of products, sum of products. And here we have this product term, that one and that one, and they are summed together. So as a result, we will get a sum of product, and that one and that one. Here we've got a complement, b complement, c, which is a product term, b, c, d complement, which is a product term, and you've got this a. This a is alone. That means it's already producted or ANDed with 1. So it's going to remain only n according to the Boolean algebra rules. Okay, so it's going to be a sum of products. Okay, there are some product terms and they are summed together, so we will get sum of products. Here we have this example. Let's see if it's sum of product or product of sum or anything. We have this product term and we have that product term and we have that product term, and as you can see they are summed together, so they are going to be called sum of products. So sum of product, here is the AB, here BCD, here we've got AC, and they are all product terms and they are summed together, so as a result we will get sum of product. And by applying the Boolean algebra techniques or rules or laws, we can easily convert any general expression to a sum of product form. For example, here we've got this term which is not a sum of product, right? It's not a normal sum of product, and this one is not sum of product, and that one is not sum of product. How to convert them into sum of product? For example, the first one is going to be this b is going to be distributed to whatever inside or between those two brackets, so it's going to be BCD and BEF. So as a result, we will get AB, BCD, EF. Look, we've got sum of product. And this example as well, this A or B is going to be distributed over the other brackets. So we will get AB, AC, AD, BB, BC, BD. So as a result, we will get sum of product. And this one, by applying the De Morgan theorem, we will get this one. And then those two complements are gone together, so we will get this one. So this C complement is going to be distributed to whatever inside the bracket, so you will get AC complement and BC. So you will get a nice sum of product expression. So far we've been talking about the sum of products or the normal sum of products, but there is something which is called standard sum of product form. And what is that? That is, for example, we've got this sum of product term. Is it sum of product? Yes, it is. We've got this product term and that one, and they are summed together. But it's not standard. Why? Because in the standard form, it says all of the domains must be included inside all of the product terms, or must be participated, or must be available in all of the product terms. What are the domains here? The domains are A, B, C, and D. A, B, C, and D. And Does all of the domain are in this product term? Look, we've got A, B, C. We don't have D, and we don't have C here, but we have D here. So if it's not available in one product term, that means it's not going to be called a standard. So how about this example? This example is AB complement C. Actually, no, it's not that one. So we've got a D, we've got ABCD, we've got ABCD. So it's going to be a standard. So sometimes we have non-standard sum of product expression. We can easily convert it to standard sum of products. So how to do that? Let's take this example. A, B complement C, A complement B complement A, B, C complement D. So what are the domains? The domain is A, B, C, and D. We've got those 4 different variables. Are all of the domain variables included in this term? No. It misses C and D, and this one misses D. So how to add those variables into those terms? We will do it. It's a straightforward method, and it's very easy. So this one is A, B complement C, and it misses D. So we can product it or AND it with 1, because if you AND 1 to a product term, nothing changes. So then it's going to be A, B complement C, 1. Okay, and then we exploit that one there to D or D complement. We know that D or D complement is 1, so we exploited that 1 into D or D complement, and after that we apply the distributive law. So it's going to be AB complement CD, AB complement C, D complement, those 2 terms. So we could easily convert that product term into standard sum of product term, or into a standard product term inside the sum of product expression. But this one misses C and misses D. So first we will add C or C complement. So it's going to be 2 different product terms. They are A complement B complement C, A complement B complement C complement, when we apply the distributive law. Again, this one misses D and that one misses D as well. So for that one, we product it with 1, you will get D or D complement, as we can see here. D or D complement, and this one again, D or D complement, multiplied or producted with D or D complement. For this one, we will get A complement B complement C D, A complement B complement C, D complement, as you can see here. For that one, A complement B complement C complement D, which is this one, A complement B complement C complement D complement, which is that one. So as a result, this one was the original one. So when we converted it to standard sum of product expression, we got this one. Okay, so as you can see, all of the domains variables are available in each product term. The product of sum is totally opposite to the sum of product. Instead, we have some terms and they are producted together. So you've got product of sums. This is a sum term, right? And this one is another sum term. So they are producted together. Okay, and this one is a sum term, and that one is another sum term, and this one is another sum term. As you can see, they are producted together, and this one as well. So here we've got a sum term, another sum term, and another sum term, and they are producted together. A sum term, another sum term, another sum term, and they are producted together. And how to convert a non-standard sum of product of some term to standard product of some term. So this is a product of sum, right? There are some sums and they are producted together. But is it standard? No, because the domain is A, B, C, and D, while the C is missing there, and the D is missing there. So the D must be available, and all of the domain variables must be available in each product term. So we will get a standard product of sum equation or expression. Look at here, all of the domain variables are available in each sum term, so we will get a standard sum of product of sum expression. Okay, in this example, we've been asking to convert this non-standard product of sum expression into standard product of sum. So it is a product of sum, right? We have some terms, this one and that one and that one, and they are producted together, but it's not standard. Why? Because all of the domain variables haven't participated in all of the products. For example, this one misses C, and this one misses A, and this one misses D. So how to add the D to this product? So we can easily say or this sum term to 0. Sorry, if you or anything with 0, we will get the same thing. Okay, so that one, A, B complement, or C, or 0. So we can exploit the 0 in order to get the D variable. So we know that in the Boolean algebra expressions, D and D complement is going to be 0. So you exploit the 0 in order to get the D. So this D is going to be distributed over the other per sum term. So it's going to be A, B complement, C, D, A, B complement, C, D complement. And this one misses A, so we can OR this sum term with 0, so we'll get B complement, C, B complement, or C, or D complement, or 0. And then we exploit the 0 in order to get the A. So 0 is going to be A complement. One time is going to be B complement, C, D complement, A, which is this one. And this one, the next time is going to be B complement, C, D complement, A complement, which is this one, A complement, B complement, C, D complement. So in this way, we could easily convert it a non-standard product of some expression into its standard. So this one is the final result, which is a standard product of some expression. Okay, how to convert a sum of product expression into truth table format. Okay, here develop a truth table for the standard sum of product expression A complement, B complement, C, and that Boolean expression, which is sum of product. So how many different variables do we have, and what are the number of the variables there? We have only 3 different variables, or we can say we have 3 different inputs. They are A, B, and C. So the number of the states in a truth table is 2 to power number of the inputs. So it's going to be 2 to power 3, which is going to be 8 different states. We generate the truth table, and that's it. And the output, we just write down 1 in the output for only those cases which are available in the sum of product expression. So we've got A complement, B complement, C. When you say complement, that means 0 input. When you say uncomplimented variable, that means the 1. So A complement, B complement, C is going to be 0, 0, 1, which is here. It's going to be 0, 0, 1, and the output is going to be 1. 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 1, 1. You'll get the output. And the remaining of the other status, the output is going to be 0.